This video is about multilingual natural language processing. In the previous video, we learned that NLP applications are powered by LLMs, large language models, and that this process demands data, massive amounts of pre-training data, and enough amount of fine-tuning data, more specialized data. Now, I have bad news for you. When we look at world languages and the amount of pre-training data and fine-tuning data available, we have enough of it for a fraction of world languages. We can look at this figure where the x-axis represents the amount of pre-training data available per language, and the y-axis represents the amount of fine-tuning data available for languages. And each dot on this graph represents a language. Now we can clearly identify English in the top right corner, and some languages are not so far from English on both axes, but the majority of world languages are much lower, and we can see that there are many languages that are very close to zero on the y-axis. So for many languages, we have no fine-tuning data at all. Now, this can be seen as a bias in the data set, where some languages, like English, are favored over other. A data set bias is one type of bias that we have in multilingual NLP. There's also another one, the model bias. And the model bias comes from how we work as a community in NLP, where the first thing we always do when we develop a new model is to develop it for English. When we find that this model is good enough for other languages, for English, we try it on other languages, but fail. And then we adapt this model. So for example, for a long time, we were using white spaces to split text into words. This works well for English, but if you see Chinese texts, and Chinese does not use white spaces to separate words, this tool does not work. Now, the result of this splitting process is words, and words have been used as the main unit of processing also for a very long time. Again, this works well for English, where words are quite meaningful units. They are relatively small. But consider the case of, for example, even Dutch, where words can become much longer. For example, employee satisfaction survey is said as medewerkerstevredenheidsonderzoek. Now, if we want to find out information about this word, looking only at occurrences of this very specific and long word, we're not going to find many such occurrences, and we're going to have a relatively poor representation of it. By contrast, if we split it into medewerker, tevredenheid, and onderzoek, we'll have many more occurrences of these different parts of the words, and we will be able to learn much more meaningful information. So, clearly, multilingual NLP is biased. There is a model bias and a dataset bias, and the result is large inequalities in access to language technologies across the languages of the world. Our group, Lagom NLP, based at KU Leuven, has as a mission to address these biases and work towards more inclusive natural language processing. We want to make NLP tools available to a larger portion of the world. And we do this by addressing these two types of biases. And in the remainder of this video, I will present some work that address each of these types of bias. Starting with the dataset bias, in this recent preprint, we looked beyond data quantity as bias and looked at the quality of data. Specifically, we looked at Wikipedia, which is a very highly used resource in multilingual NLP. It is fairly easy to download from the web, and you can have data that is somewhat parallel in many languages. And it's considered a high-quality resource by researchers. Now we investigated if it is the case that it can be seen as a high-quality resource, and found that this is not so much the case for all languages. For example, we found that many articles are extremely short. This here is an article in Cebuano about the country Germany, and it has only 2 sentences. This article here is supposed to be in Urdu, but it is actually in English. More generally, we found that there is a large variation in the quality of Wikipedias when looking at different languages. And we found that we can actually filter up to 50% of the data of a specific Wikipedia for a specific language with very little impact on performance. The performance of NLP models was not hurt by this filtering, meaning that we were wasting computing resources using data that is not actually helpful to the model. Another type of bias that we're trying to address is the model bias. And specifically, we're questioning what should be used as the main unit of representations of LLMs. In the last video, we saw that LLMs are trained to predict upcoming words in text. In reality, this is a simplification. If we were to predict upcoming words in text, we would have a very large vocabulary. And this would make the task very difficult and problematic from a computational perspective. In practice, what is used as the main unit of representation in large language models is called a subword. A subword can correspond to a word in the case where it is frequent enough. For example, the word meet, the word everyone, the word they. But in the case of a rarer word like unicorn, it is split into smaller units. So effectively, subwords reduce the vocabulary size and make the model more computationally efficient. And these subwords have become the de facto standard, the de facto unit of processing in NLP, and it has been found that they work reasonably well when we work with English. However, if we use subwords as the main unit of language representation for other languages, they are not so meaningful. We can see here our example medewerkerstevredenheidsonderzoek split into subwords, and we can see that the result is units that are not very meaningful, such as reden. Now, how do we address this? In this recent work that we published last year, we proposed that instead of using subwords as the main unit of language processing, we use patches of pixels instead. How do we do this? We take an input sentence and first render it as an image and split this image into patches of pixels, and then we mask some of these spans of patches, and the task of the neural network is then, instead of predicting words, it is to reconstruct the image. So effectively, what this approach does is to bypass the need for a vocabulary. We don't have to define a finite vocabulary, but rather we can work with these image representations instead. And empirically, we found that this is a viable alternative for language modeling. It learns something about language, and it has advantages when it comes to multilingual modeling. So what have we learned in this video? We've seen that there's clearly inequality in access to language technology across languages of the world, and that this is due to a dataset bias and a model bias. We've seen attempts that we've made in our group to address these biases. one by filtering Wikipedia based on quality, and another by changing the main unit of representation of language models from subwords to pixels. More generally, what we aim or ambition as a group is to have multilinguality, to put multilinguality at the core of the field rather than at the periphery.